From above, Jakarta looks like a city built for the future. High-rise towers dominate the skyline. Highways cut through neighborhoods that stretch almost endlessly toward the horizon. Millions of people move through one of the most important urban regions in Southeast Asia. But along the northern edge of the city, something is happening that cannot be seen from a skyscraper. The ground is sinking. Not metaphorically, not over hundreds of thousands of years. The actual surface beneath parts of Jakarta has been moving downward. And as the land loses elevation, the sea does not have to rise very far to become a threat. Walls have been built to hold back tidal water. Pumps move water out of neighborhoods that can no longer drain naturally. In some places, the city has changed so much in elevation that gravity alone is no longer enough to move floodwater toward the ocean. Jakarta is often described as a city being swallowed by rising seas. But that description misses the most disturbing part of the story. The ocean is rising, but Jakarta is also moving toward it. And for decades, one of the forces driving that process has been coming from beneath the city itself. This is the story of a megacity slowly losing its ground. Jakarta was built on a difficult landscape. The city sits on a low coastal plain on the island of Java. 13 major rivers flow from higher ground toward Jakarta before reaching the Java Sea. During the rainy season, huge volumes of water must pass through a city covered with roads, buildings, concrete, canals, and dense neighborhoods. Flooding is not new here. For generations, Jakarta has dealt with heavy rainfall, overflowing rivers, tidal floods, blocked drainage systems, and water flowing downstream from higher areas south of the city. But another problem has made all of those hazards more dangerous. The elevation of the city itself has changed. Older studies found extremely rapid land subsidence in parts of Jakarta. In some localized areas of North Jakarta, measurements once reached between 15 and 25 centimeters per year. Those numbers became famous. They produced headlines claiming that Jakarta was sinking by 25 centimeters every year. But that description is misleading. The entire city does not sink at one uniform rate, and the rate has changed over time. More recent monitoring reported by Indonesia's National Research and Innovation Agency found that subsidence in Jakarta had slowed significantly compared with some earlier periods, with maximum rates of around 5 centimeters per year in monitoring from 2015 to 2020. 5 centimeters may sound small, but for a city, it is enormous. 5 centimeters every year is half a meter in a decade if that rate continues. And even slower subsidence accumulates. A road sinks relative to a seawall. A drainage channel loses its slope. A neighborhood that once sat safely above high tide becomes harder to protect. The problem is not simply that Jakarta is getting lower. It is that everything designed around the city's old elevation becomes less effective as the ground moves. And the reason for much of that movement begins deep underground. The city needs water for drinking, for washing, for hotels, factories, offices, restaurants, apartments, and millions of homes. But for years, Jakarta's piped water network could not fully meet the needs of the entire city. So many buildings turned to another source: groundwater. Wells drilled beneath Jakarta allowed residents and businesses to pump water directly from underground aquifers. At first, this seems harmless. The water is already there. Pump it out, use it, and allow rainfall to replace it. But beneath a city this large, the system is not that simple. Groundwater occupies spaces inside layers of sediment. When large amounts of water are removed faster than the underground system can recover, pressure inside those layers can fall. Sediments can compact. And once some of that compaction happens, the lost elevation may not simply return when the aquifer refills. The ground itself becomes lower. Jakarta makes the problem even more difficult because so much of the surface is covered by buildings and pavement. Rainfall that might once have soaked into the ground is instead directed into drains and canals. So the city can experience an extraordinary contradiction. There can be too much water above the ground and not enough water being restored beneath it. Flooded streets on the surface, depleted aquifers underground. And the more the city sinks, the harder it becomes to remove the next flood. This is why groundwater extraction has been repeatedly identified as one of the major drivers of Jakarta's land subsidence. It is also why building higher walls along the coast cannot solve everything by itself. A wall protects against the sea. It does not stop the ground behind that wall from sinking. To address that, Jakarta needs something much less dramatic than a giant barrier. It needs reliable, clean water. Because every home, hotel, factory, or office connected to a dependable water supply is one less reason to keep pulling water from below the city. But even if groundwater extraction were controlled tomorrow, Jakarta would still face another problem: the water already surrounding it. Jakarta does not experience one type of flood. It experiences several. Heavy rainfall can overwhelm local drainage. Rivers can carry floodwater from upstream areas into the city. And along the coast, high tides can push seawater toward low-lying neighborhoods. These events can happen separately, or they can happen together. Land subsidence makes each one harder to manage. Imagine a drainage canal designed to carry rainwater toward the sea. Gravity works because the water starts higher than where it needs to go. But if the city slowly sinks while the sea remains at roughly the same elevation, or rises, that difference becomes smaller. Eventually, gravity stops being enough. Water must be pumped. The World Bank has documented parts of Jakarta where severe subsidence meant overflowing waterways could no longer be emptied toward the sea only by gravity. That changes the entire logic of the city. A normal coastal city tries to keep water flowing outward. A sinking coastal city increasingly has to lift water outward. That means pumps, electricity, retention basins, canals, gates, maintenance, and infrastructure that has to keep working during the exact storms when it is needed most. Meanwhile, global sea level rise adds another layer of pressure. It is important to separate these two processes. Climate change is not the main explanation for Jakarta's historic, rapid land subsidence. The land has been sinking much faster in some periods and locations than global sea level has been rising. But sea level rise still matters. If the land moves downward while the ocean moves upward, the relative difference between them changes from both directions. For people living behind coastal defenses, that difference is what matters. A few centimeters of sea level rise becomes much more dangerous when the ground beneath a neighborhood has already fallen by tens of centimeters. And so, Jakarta has responded with one of the oldest strategies used by coastal civilizations. Build a wall. Then, build it higher. Along the coast of North Jakarta, seawalls are not an abstract climate project. They are physical barriers between neighborhoods and tidal water. Indonesia has spent years strengthening coastal defenses under plans connected to the National Capital Integrated Coastal Development Program. By 2025, the Ministry of Public Works reported that more than 12 kilometers of an earlier coastal protection phase had been completed, with additional sections developed together with the Jakarta provincial government. Further sections remain under planning and feasibility studies, and the ambition has grown much larger. The government has discussed a giant coastal protection system extending far beyond Jakarta along the northern coast of Java. From above, walls and barriers can look like the obvious solution. If the sea is outside, keep it outside. But Jakarta's water problem comes from more than one direction. Rain still falls inside the wall, rivers still flow through the city, wastewater still has to go somewhere. And if the land behind the wall continues sinking, the protected area can behave increasingly like a basin. That means a seawall cannot operate alone. It must be connected to pumps, drainage, wastewater systems, reservoirs, river management, and reliable freshwater infrastructure. In other words, Jakarta cannot simply build one enormous wall and declare the problem solved. The city has to function more and more like an engineered water system. And every engineered system creates a new question. What happens if maintenance fails? What happens if pumps lose power during extreme weather? What happens if the ground keeps moving beneath the infrastructure designed to protect it? This is why officials themselves connect coastal defenses with reducing groundwater use. Stopping the ocean is only one half of the equation. The other half is stopping the city from continuing to sink. Jakarta's sinking problem is often presented as a climate change story. That is only partly correct. Groundwater extraction and the compaction of sediments explain much of the dramatic land subsidence. But climate change makes the consequences more difficult to control. Sea levels are rising. Warmer oceans increase the background level from which storm surges and high tides begin. Extreme rainfall can place additional pressure on drainage systems, and Jakarta already sits at the downstream end of a large river basin. This means the city is fighting water from three directions: from the sky, from the rivers, and from the sea. Meanwhile, the ground beneath parts of the city has been moving in the opposite direction, down. This creates what engineers sometimes describe in terms of relative sea level. For someone standing behind a seawall, it does not matter whether the ocean rose 20 centimeters, the land sank 20 centimeters, or both moved 10. The result is the same. The water is now 20 centimeters higher relative to where that person is standing. And that is why Jakarta's future cannot be understood using a single dramatic statistic. There is no countdown clock showing the year when the entire city disappears beneath the ocean. Jakarta will not suddenly vanish like an island in a disaster movie. Different neighborhoods face different elevations, different rates of subsidence, different levels of protection. The real danger is slower, more expensive, and in some ways more difficult. Every centimeter changes the amount of engineering required to keep parts of the city dry. And while Jakarta works to defend itself, Indonesia has begun building something extraordinary more than 1,000 kilometers away: a new capital. On the island of Borneo, Indonesia is building Nusantara, a new administrative capital designed around a radically different vision of urban development. Green space, public transport, modern water infrastructure, digital systems, lower emissions, and a city planned before millions of people arrive, rather than rebuilt around them afterward. The decision to create Nusantara is sometimes described as Indonesia abandoning Jakarta because it is sinking. That is too simple. Jakarta's environmental problems were one part of a much larger debate involving overcrowding, congestion, development concentrated on Java, infrastructure pressure, and the desire to redistribute economic activity. And moving government offices does not mean moving Jakarta. The city remains an enormous economic and population center. Millions of people will continue living and working there. Ports, businesses, homes, roads, railways, factories, and entire communities cannot simply be relocated to another island. Nusantara also remains a long-term project rather than a finished replacement city. Its official development plans continue through 2045. Construction and investment were still continuing in 2026, including new smart city planning partnerships. So the existence of a new capital does not remove Jakarta's problem. It actually highlights its scale. Indonesia can move ministries. It cannot move the coastline. It cannot move millions of homes. And it cannot lift entire neighborhoods back to their former elevation. Jakarta still has to adapt. The word sinking makes Jakarta sound doomed. But land subsidence is not an unstoppable natural force. Other cities have experienced major subsidence and slowed it by controlling groundwater extraction and expanding alternative water supplies. Jakarta itself has already shown signs that subsidence rates can change. That matters, because the difference between sinking 20 centimeters a year and sinking a few centimeters a year is enormous. And the difference between a few centimeters and near stability is even more important. The solution is not one giant project. It is dozens of systems working together. Expand reliable piped water so fewer people depend on groundwater. Control illegal wells. Protect and restore aquifers where possible. Maintain canals. Improve drainage. Operate pumps. Manage rivers upstream. Strengthen coastal barriers. Treat wastewater. And constantly monitor how the ground itself is moving. None of this is as dramatic as a city disappearing into the ocean. But that may be the real lesson of Jakarta. Cities rarely fail in one cinematic moment. They become harder to maintain, more expensive to protect, more dependent on infrastructure. A wall needs to be raised, a pump needs to become larger, a road floods more often. A house that once stood above the tide now depends on concrete barriers to remain dry. Jakarta is not disappearing tomorrow, and it is not sinking uniformly. But parts of the city have already lost meters of elevation over decades. That history cannot simply be reversed. The challenge now is to stop adding to it, because there is a major difference between a city protected from the sea and a city that must keep building higher defenses forever. Jakarta's story sounds like a warning from the future. A vast coastal city, a rising ocean, flooded streets, and walls holding back the sea. But its darkest lesson actually began underground. For decades, water was pumped from beneath a growing city. Slowly, almost invisibly, the land responded. Buildings remained standing, traffic continued moving, new towers rose into the sky, but the surface beneath them changed. That is what makes land subsidence so dangerous. There is no wave when it begins, no earthquake, no single moment when the ground suddenly disappears. Only measurements, a few centimeters, then a few more. Until one day, a wall that once protected the city is no longer high enough. Jakarta is fighting to change that future, with water systems, pumps, coastal defenses, and an effort to reduce the pressure that helped create the problem in the first place. The city is not being swallowed by the sea, not yet. But in some parts of Jakarta, the distance between the streets and the ocean has been getting smaller for decades. And the race now is to stop the ground from losing first. This is Dark Atlas.